example 5. And this one is the hyperbolic paraboloid. So it says sketch the surface z equals y squared minus x squared. Alright, so continuing further, so let's take a look at the solution. So the traces in the vertical planes x equals to k, so when you put in k, are the parabolas z equals y squared minus k squared, which open upward, but this just indicates they're shifted down, and then it goes above the origin there. So the traces in y equals k are the parabolas z equals, so when you have y equals to k like this, plug that in, so put the negative x in front. So we'll have z equals negative x squared plus y squared, which open up downwards. Yeah, which open downwards because of this negative there. So when you have x is positive, then the z is going to turn into negative going downwards. And this one shifts this up, and it's going to go down. So it's going to be shifted up and going down if this is the origin there, etc. And this other one is the opposite of that. Is going to go up like that, but it's going to be below the origin if k is a positive number. All right. So the horizontal traces is when z equals to k. So when z equals to k, just put it in k there. So we'll have y squared minus k squared minus x squared equals to k, a family of hyperbolas or hyperbolas. And we can see that from our conic sections. There's a hyperbola, so x squared divided by a squared minus. So there's that minus as opposed to the plus for the ellipse. So minus y squared divided by b squared equals 1. So epic stuff there. Alright, going further, we can draw the family of traces below and show how the traces appear when placed in their correct plane. So this is going to be actually the hardest, most tedious one manually, but it's pretty epic stuff what shows up. So for example, let's say the first one, so the first trace is the vertical ones, x equals k, and then we'll have this z equals y squared minus k squared. So if we have this in 2D, I'll go x squared x equals to k, so we're going to get the traces z equals to y squared minus k squared. And then so if we draw this in 2D, if this is the z-axis and this is the y-axis, we're going to have, so at k equals 0, we just have a basic parabola. This is at, remember, the k just shifts it, so we're going to have z equals to, or just always just put k equals 0. And then at k equals 1, this just goes to the 1. So it's going to be just all parabolas, just k equals 1. And then shift this below, like this. We're just going to have another one, k equals 2, etc. Or k equals plus or minus 2. And yeah, this is because it's squared, because we have the square there, so it doesn't matter, it's always going to be the same value there, if you have plus or minus. And so now, if we do this in 3D, so this is the y equals k plane. Yeah, so in 3D, this is going to be the hardest part. So I'll just draw the z-axis and the y-axis here. And this is the x-axis. So we have to visualize everything in 3D. So let's draw the, this is at k equals to 0. So x equals to k, which equals to 0. And it's just going to be a basic parabola. And this is going to be on the zy plane. It's going to be just basically like that. So that is what we have right here. This is at k equals to 0. The k equals, yes, the x equals to k equals 0. So x equals to k equals 0. Now the next one, let's say we had plus or minus 1. So the first one's going to be plus here. So across this plane, we're going to have this right here is going to be below it. So instead of this, it's actually going to go, it's going to go 1 here. So 1. And then below 1. Yeah, and it's going to be, because 1 squared is just going to be below. Like that. Yeah, so this is positive 1. Well, and I'll do is draw another line, make this extend this further. That's positive 1. This is going to be plus 1. This is going to be minus 1. And then we're going to subtract by that. This is the k. So then the parabola here is going to be below here. But this one, imagine this, you're looking at the 3D like directly from the x-axis. So now this is going to be below it. It's going to look something like this. This is going to be below all the way to 1. I'll draw this across here. This is going to be minus 1 because you're subtracting by 1. And it's going to be on both sides. So it's going to be minus 1 as well over here. It's going to look something like this. This goes through and so on. Actually, what I'll do is I'll draw it in different color. Alright, I'll erase this, and I'll draw it in different color. Alright, so let's draw this in red. So that's this part here, and this part here. It's gonna go like it's gonna be, yeah, it's, again, you're drawing in 3D from an angle there, and this one here is gonna be k equals to -1, and this one is k equals to 1. So they're the exact same, but just shifted. K equals +1. So it looks like that. Yeah. So the peak is gonna be at the origin from the bottom part. It's gonna be so the bottom peaks or the bottom saddles or whatever these are called. It's the bottom there. Or the troughs, it's going to go higher and higher to the origin and go back down. So that's an indicator of how the shape's going to be. Alright, so that was the x equals k, the vertical one. Now the next one, so the other one is the other vertical one is y equals k. So the parabolas, so when you have y equals to k, we're going to have z equals to -x squared and then plus y or k squared. So let's write that down. So we'll have y equals to k. So we're going to get z equals to -x squared plus k squared. So these ones are going downwards now. And this, let's draw this in the this is going to be, yeah, this is going to be our, so k is so that now we're going to have z, and now we're going to have the axis is going to be x. So before it was z and y, now it's going to be y, z and x because the other one's gone. And this is going to go, so when k is 0, that's just going to be -x squared, so it's just going to go downwards like that. So this is k equals 0. And I'll put that inwards. K equals 0. The next one is going to be k equals to plus or minus 1. And so these goes upwards. So they start from up and then go down. And so on. This below it. I'll just go k equals 2 plus or minus 1. The next one is going to be like that. And this is going to be k equals 2 plus or minus 2, etc. Alright, so in 3D now, this is getting interesting. Okay, so in 3D, this is going to be like this. This is going to be y, this is going to be z, this is going to be your x. So now we're going to be going, well, y is the one that's going to be the k, this is going to be changing. So at y equals to k equals 0, we just have the basic one going downwards, and it's going to go downwards on the z plane, so it's going to go like this. It's going to go down like that. I'll draw it like that. So that's how it looks like, and this one is at our k equals to 0, or y equals to k equals 0. So I'll just put that just for completeness. So y equals, just to make it easier to understand on my end. So y equals k equals 0. And then the next one is going to be, well, over here. This is going to be shifted up. So then this is going to be plus or minus 1. So let's go to the -1. It's going to go across here, -1. And then -1 is going to be higher up by 1. It's going to go downwards like that. So now, and I'll draw this in red as well. Alright, yeah, let's draw that in red. So it goes across here, and it's going to go like that. So that's the red. This one is at our k equals to -1. And then likewise, we're going to have exactly the same thing, but then now we're going to be shifted over to the 1 and 1. So it's going to be starting up above like that and going down like that. So yeah, going through that there. And this one is at our k equals to +1. Epic stuff. Yeah, and then somehow we have to combine all these together. So this one goes like that and goes down. This one, this side goes like this somehow. And yeah, and this one goes down and up like that on that side. Alright, so now the next one is the horizontal traces. That's going to be at z equals to k. We're going to have y squared minus k squared. So yes, equals to k. So we're going to have now the z equals to k, and now we're going to have our basic y equals x 2D graph. This is going to be now, let's see what it was again. So yeah, this is going to be y squared minus x squared equals to k. Y squared minus x squared equals to k, like that. Alright, now this shape's gonna be, this is a hyperbola. It's gonna look something like this. So if we recall a hyperbola, this is gonna be our x. So the distances, and this is gonna be the y minus x, this is gonna be actually a vertical hyperbola. And this is gonna be like this. So let's say we had k equals to 1. you can't have k equals to, well, k equals to 0. If you have k equals 0, you're just going to have 0 and 0. It's going to be like this. Actually, no, you can't have 0. So if it's equal to 0, so if we have, let's say if it's equal to 0, we're going to get, we're just going to get a straight line like this. So this is how it looks like if k equals 0. So k equals to 0 is here. And this is because, well, we're going to get y squared minus x squared equals 0. In other words, we're going to get y equals to x, and everything cancels out. So basically y equals x, and then plus or minus, if x is negative, it goes down, perfectly straight line like that. And then at this point is going to be our, so if we had, yeah, so this at this point now here, this is at k equals to plus, yeah, this is at k equals plus 1. Actually, not plus 1, just this is just at k equals 1. And it's a hyperbola, so we get two shapes like this, like that. And this is k equals to 1, like that. And here I quickly teleported just to recap on that hyperbola. So it's divided by a right here. For this case, we have y squared minus. And it's since it's 1, these values are just going to be 1 there. Right, going all the way back down. So this is going to be 1 or 0, 1. This one here is going to be 0, negative 1, like that. And that's because it's y squared divided by a squared is, and a is just 1. 1 squared is 1. Alright, so now graphing this in 3D. That gets next level. So we have it in 3D. Let's look how it looks like. It's going to be our z. And this is going to be our y. This is going to be our x, like that. And let's graph the k equals 0. That's just going to be our straight lines across it. Like that, and like this. What is the y-axis? So that's this is the y-axis, rotate that around. So that's our k equals to 0, or z equals to k equals 0. Now when z equals to 1, draw this in red. Alright, so draw it in red, and it's going to be a hyperbola on the top side. That is when you'll have a horizontal trace. So this is going to be at 1. Yeah, and that's going to be at 1, and it's the same thing. Then on the negative side, yeah, so then the other one is if you had a negative 1 here. All right, and now before we get further drawing this one, let's draw this part here. I forgot to do this one and make this a bit nicer. It's supposed to be actually like an asymptote line to this section right here. It's supposed to actually go closer and closer to it. But anyways, it's close enough. I'll show the image of my calculus book for more clarity. So anyways, the next one is when we have k equals negative 1. So if k equals negative 1, this will be a negative 1, and then to make it positive, we'll move it over. This becomes positive, the y becomes negative, and we get a basic horizontal parabola. I'll just put it in like that. And it's going to look, yeah, it's going to look like this. And this is at our k equals to negative 1. This one is, I'll put there are the lines. K equals negative 1. And this value is going to be 1, 0. And likewise, it's going to be popped like that. This is going to be at our negative 1, 0. Like that. And again, at k equals negative 1, we're going to get a x squared minus y squared equals to 1. So it's switched up around. It's a negative sign there. Anyway, so we have that. So this is going to be, that's the y and that's the x opening up on the y side. That's the y. Now we're going to draw this in red. Draw this in red. And this is going to be at the this part right here. And this is going to opening up on the y. It's going to look something like this. It's going to be so hard to draw in 3D. It's going to look something like this. And it's opening up. That's 1. It's also distance 1. Be something like this, and then the other side, negative 1 on the y side. And this is going to be, yeah, extending out like that. It's going to be something like that. Like this. Alright, and now this one is for the k equals plus 1, or the z equals k equals plus 1. And now, and this the bottom one is the z equals 0. That's this line across. And now what I'll do is, well, we got to draw now the, I'll do that in blue, but before we get to that, I'm going to extend this down. This is the z-axis, and also the x-axis across that way. And now what we're needing to do is I'll draw this in blue, and this is for the k equals -1. So the k equals -1, that's going to be, well, it's going to go across, it's going to go down here, -1. And then it's going to go across, we got to go to the 1 on the x-axis. It's going to go ... all the way till the 1 here. And then we start here, now we open up along the x-axis, so in 3D. Picture that. And open up like that. I'll put it like this. Yeah, and then we go along on the back side. We go to the -1 here, go down, and it's going to open up this way. And so on. So again, it's very, very hard to do manually. And yeah, I'll show the calculus book image soon, but now if we put this all together and see what happens, or actually we'll just show the calculus image right now. So for clarity, here are the graphs for my calculus book. So this is doing manually just to illustrate the process, but here's the calculus book right here. So traces in x equals k, r, z equals y squared minus k squared, so it opens up upwards like that. And then you'll have, and these are for different values of k across there. And then traces in y equals k, r, z equals to -x squared plus k squared. It goes down like that. And then traces in z equals to k are this right here. And note also when k equals to 0, you just get a straight lines across that. And then when traces in x equals to k, the vertical one, you're gonna get, yeah, I mean this one here, you put it down here, so it's exactly like what we had. Traces in x equals to k, like this goes, it goes down, then up, then down. And that's similar to what we had here. And then likewise for the traces in y equals k goes like this. It's like a saddle like that, and it goes this way here. So that's what we had. And then finally the advanced one, the hyperbolas, this right here. So traces in z equals to k, you have -1 at the bottom. This is the lines at the 0, and then you'll have the ones opening up on the y. This is for the k equals 1. That's this right here. So compare that with mine. It's very hard to see. This is, again, computer graphics there. So if we fit the traces, or fit together the traces, we can form the surface z equals y squared minus x squared, which is a hyperbolic paraboloid. All right, so let's try to do this all manually. So what's going to look like? It's going to look something like this. And then the shape. Yeah, the shape actually saddles down like this somehow, and then goes up, and it opens up like this, and so on. So it looks something like this, and this is the x-axis. This is the x, this is the origin there, this is the y, and this right here, I'll fix this up. Something like this actually, and it goes upwards like that, and so on, and then this goes out like that, y. This is dash dash, like that, and then this part right here goes down, dash dash dash, and then goes like this. This goes opens up like this. A curve, and then this goes like this, like that, 0, and you can see this is how the shape looks like. It's kind of like a saddle, and you can see that, well, we're gonna combine this all together. So if we combine this part right here, this is on the x-axis, going to go up and down. So we'll have this right here. Yeah, should be a bit lower. Yeah, so it should be a bit lower. So this, and this is below, so it's hard to see without shading. But you're going to see this is going to be, we draw a trace like that. So there's our parabola at the bottom. That's actually this one right here at the bottom, and now we have the saddle on the top there. And then this one here is that one at the 0. Then at the bottom, it's going to go down, but they're all parabolas going like this. They're all going down, but this is below it, and then it's going down on the further side. And then now it's opening up at the lines like that. And the interesting part is this actually goes a line perfectly on that on that hyperboloid, so that those lines actually fit perfectly along it. And now this is expanding outwards and expanding like this, like a hyperbola, like that and that. So that's how it looks like. And yeah, now going further, so for clarity, here's the graph from my calculus book. So it looks like this. How much nicer than mine. Well, actually, mine's pretty good here. Yeah, it's pretty good. And yeah, it looks like that. And then if we graph this in GeoGebra, so plug this in, z equals y squared minus x squared, we get this this saddle like that. All right, let's open this up again. All right, so here we are right here, and there's our graph like that. You just hadn't showed. And yeah, it looks like the saddle. You could rotate it around, and it's pretty epic looking saddle there. It's actually what it's called as a nickname. All right, so that's pretty epic, and it goes up, and you can zoom in, and so on. And yeah, that's quite fascinating. All right. And yes, so notice that the shape of the surface near the origin resembles that of a saddle. This surface will be investigated further in a future video when we discuss saddle points.